Hello all my JavaScript friends, this is the Virtuoid, aka Mike Smith, and this is Fun with JavaScript, our Jigsaw puzzle game. Now in our last video we took a look at the deconstruction of our Jigsaw puzzle.javascript file into our graphics puzzle.javascript file, which is basically the file, I got it listed here. This is the file that controls the full puzzle itself. The next thing we're going to look at is the graphic piece, and the graphic piece controls the graphical representation of each individual piece itself. And of course, obviously, graphics puzzle is going to need it. There's going to the patterns are going to need it, and all that kind of fun stuff. So let's take a look at some code. I'm going to first go to the graphic, and I'm going to create a JavaScript file, and I'm going to call it GraphicPiece. There we go. We're going to export default class GraphicPiece. Yeah, E. Make sure I spell that right. All right, we've got that part done. So we need to take a look at, I don't think that Jigsaw Puzzle needs to have the piece. It does not. Does Graphic Puzzle need to import the piece? I think it does. I just want to just check and make sure. Actually, it does not. It does not at all. It just gets patterns. So we have to worry about that. All right, so let's go ahead and throw some code inside the piece, and we'll take a look and see what there is to see. And through the magic of television, we have the graphic piece. Now we are extending the original piece JavaScript file, so we're going to miss the import statement. So let's throw that import statement inside there. Ta-da! We're in good shape there. So basically the graphic piece itself represents a single piece of the puzzle. And what do we mean by the single piece of the puzzle? Well, obviously we have 16 pieces. I'm going to show an example here. We have the 16 pieces on the board. Each individual piece that you see there is represented by a graphic piece. And a graphic piece has within it a graphic image, and that image is the physical image itself. But the piece will be stored within it. The position it is within the board, plus a couple of other fun little routines like set and position and all that will help the puzzle be able to manipulate the piece, and also help the pattern to be able to manipulate the piece. So let's go ahead and go through a couple of things here. When we do a constructor for the graphic piece, what we have is we're going to pass it the width, the height, the image, the ID, and the vertices. And the image is going to be the small cut piece of the image. It's not going to be the full image that we're looking at, but if you can think of, in our particular case, we have the 16 different pieces. It will represent just that one single cut piece. And we're going to check to make sure that everything is okie dokie. We're going to save all the data. We're going to save the Z index. That's going to be very, very important. We're going to create a span element, and oh, I could have cut that out. See, I still got some code I haven't cleaned up yet. So obviously I didn't need to do that. I set the ID on there, and then I'm going to create something called a graphic image, and we'll cover the graphic image in another video. But the graphic image will contain the actual image. It will contain the image itself. It will contain a pointer to the canvas. We're going to contain a pointer to the span, because basically each individual piece within the puzzle is going to be a span, and within an absolute position span, absolutely positioned within the board, and each graphic image is going to be a single canvas image within that piece, and also absolutely positioned. And when the pattern gets a hold of all this and we combine two pieces together, we're actually going to still just have one span, but we're going to keep adding graphic images to that span and do the correct offsets. And again, when we do the pattern, which is going to be a really intense little video, everything will kind of come together there. But suffice it to say, our graphic piece here has the span in it, while the graphic image will have the canvas, or a pointer to the canvas. So we're going to create the graphic image. We're going to set the image itself. We're going to append that image to our append child. What I've done here is I have a variable called DOM for each one of these. So I will know that when I want to access the actual DOM of the piece, I will just say piece.dom. If I want to access the DOM of the image, I'll just say image.dom. If I want to access the DOM for the puzzle, I'll say the puzzle.dom. So that's kind of my little nomenclature to saying, hey, or my standardization, that whenever I say .dom, I'm pointing directly to the actual DOM elements. So that's no big deal there. I want to show you this, and we do add the graphic images. I want to keep track of what images are associated with this piece, because eventually what the pattern will do is that when we connect two pieces together, we're going to merge two of the pieces together, and the image from the second piece is going to be appended into the span of the first piece. So I'll have one span but two different images, and I want to keep track of those different graphics images. We get the width of it, and what the width will actually do is it will take a look at every single one of the graphics images and figure out, based upon the offset left of each of the graphic images, it will attempt to figure out the width of the entire, it will try to figure out the width of the image itself. And the whole purpose of this is that obviously I could have some very weird looking pieces, as if you took a look at our video from when we explained what we're going to be doing. I had just two very weird pieces, not just simple squares. When you have that, I've got to be able to get all the different images within the piece to be able to and put them all together to try to figure out what the actual width is. And the same thing with the height. To get the actual height, I've got to look at each of the individual images. I can't just sit there and rely upon a set image or a set height for the span. It's going to be dynamic. So because it's dynamic, I'm going to go to each one of the individual images to figure out, hey, this is the full width of this span, or this is the full height of the span. And to get image, get down, get top, get left, get ID, get blah, 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 no big deal here. I do get the graphic images, which according to my ID, I don't use anymore. That's good, okay? Very important here with the get the vertices. And now when we get the vertices, what we're having to do here is I want to be able to get the vertices of the different pieces. To kind of give you a little spoiler for the pattern, when we take two different pieces and put them together, we basically have 8 different vertices. And with 4 different vertices, in my particular case, you have 4 vertices for one piece and 4 vertices for another piece. When you put them together, you're going to have 8 different vertices, and I need to keep that count. But again, just like with the height and the width, that's all going to be dynamic based upon the images that are inside there. So I'm going through all the different graphic images, and I am concatenated all the different vertices for all the different images. So if I had 3 pieces within one particular span, 3 graphic images, then I should end up with 12 vertices. So this get vertices, this little getter function, whenever I say, piece dot vertices, this is going to return an array of all the different vertices of all of the different images contained within that piece. Z-indexes, apparently I don't use the Z-index either. I didn't know that. Set position is extraordinarily important. The puzzle has got to be able to tell the piece, hey, you're at this new position on the board. Deal with it. And so I say, yes, sir. And I sit there and I set the style for the top and the left. Here, and actually I don't even use it just in position anymore. This is what's extraordinarily important and what I really wanted to point out here within the graphic piece. So, if you recall correctly, and I'll put a little video up here or some graphics images up here to help remind you, we have something called vertexInfo. And what the vertexInfo basically does is it says, I have a vertex on this particular image that is located on this image at this particular location. So basically we have a simple square, for example, just a single square image. We're going to have 4 vertices on there, and the vertex locations are going to be 0, 0, 0, and the width of the width of the piece, the height of the piece, comma 0, and the height of the piece, comma width of the piece. Those are going to be the 4 vertexes. And that's fine, but what I discovered is when I put 2 pieces together, I had a lot of problems trying to get the vertices to recognize each other. So I created what I call the vertexInfo, in which each vertex within the piece had the left and right where it was positioned, but it also had a vertex pointer inside of it that said, I'm vertex number 4, I'm vertex number 5, I'm vertex number 6. So for instance, in my case, the upper right-hand corner of a particular piece would have vertex information of a top of 0 and a top of 0 and a left of the width of the piece, but would have a vertex pointer of 5, for example. While the other piece in the upper left-hand corner will have a top of 0 and a left of 0, but will also have that vertex pointer being 5. And by doing that, I know now that I can be able to I can get connections between those two pieces there. So what this get vertex info does is it gets the vertex info from all the different graphics images based upon this particular vertex ID. And this vertex ID will be generated from the map. So I have a map within my, I have a map of all the different I'm sorry, let me back that up here. The graphic image has a vertex ID. And so when I go into the system and say, hey, graphic image, give me this particular vertex ID, it's going to come back and say, oh, here's vertex ID 0 and the left-right information for the vertex ID 0. So once I do that, I should end up with a graphic image. If I have a graphic image, I get the vertex info of that particular graphic image. This right here just basically tries to find it for me. And I get the vertex info of that. And if the vertex info is there and valid, I then return the top, the left, and the relative top and the relative right of the vertex info. So what this will allow me to do is, if I need vertex number 5, I get the true position of that vertex based upon the board itself instead of based upon the span, because each of the images within the spans are absolutely positioned based upon the span. So I have to add the spans offset top and offset left in order to be able to get the true position of that particular vertex in relationship to the board. By passing all that information, if I'm checking vertex number 5, for example, I can get the real location of vertex 5 for this piece and the other piece. And if they're within 3 pixels for both the X and the Y, we got a match. If not, they don't. So the whole idea between vertex info for this particular vertex ID is to get the real X, Y location of that vertex ID if that vertex is located within this particular piece. I mean, the X, Y info, the top left info, based upon or offset from the board and not from the span. And that's basically all there is to the piece. There's really not a whole lot that there is to the piece, except the most important thing here is that because it's dynamic, anything that has to do with the size of the piece, the vertices that are within the piece, or any particular information on a particular vertex, everything is based upon the dynamic changes of the images that are within the span. That was one of the keys of getting the puzzle pieces to work correctly. But that's generally all there is to the graphics piece. Not a whole lot here. The next thing we're going to take a look at in our next video is we're going to take a look at the graphics, the graphics image itself, which will also include the graphics vertexes. Thank you very much for watching. If you like this video, please click on the like button below. If you wish to keep informed about new content, click on the subscribe button. And as always, please leave a comment below. I'd love to hear from you. Again, thank you very much for watching. This is the Virtuoid, aka Mike Smith. We'll see you later.